So hello everyone, let us solve today's GfG problem of the day, and the problem name is minimum number of deletions and insertions. So let us read the problem statement. So given two strings str1 and str2. Now our task is to remove or insert the minimum number of characters from or in str1 so as to transform it into str2. So what the question is saying that we are given str1 and str2. Now we need to transform this str1 to str2 by minimum numbers of deletions or insertions of characters. Now it could be possible that the same character needs to be removed from one point of str1 and inserted to some another point. Now this means that if a particular character or alphabet is present at some location, now that character might not be present at the same location in str2, that might be present at some another location. So in str1 we might need to remove that character once and then insert that again to the desired location. So that is what this line means. So let us see this first example and try to understand the question and try to find some solution out of it. So this is the first example that they have given, and string 1 here is heap and string 2 here is p. Now what they are saying, we can either perform deletion operation or we can perform insertion operation to convert this string 1 into string 2. So let us see how we can convert this string 1 into string 2. Now first what we can do, we can remove this h and p. So what we will get e and a. So till now we performed two deletion operations. Now this string is not equal to string 2, so we need to again perform some operations. Now what we need to perform operation, you can see that this ea and this ea is common. The only thing we need to do now is add this p. So after adding this p, our string would look like this, pea. Now we can insert at any position. So yeah, we inserted at the beginning. Now this string 1 is equal to string 2. So we performed one insertion operation. So in total we performed 3 operations, 2 deletion and 1 insertion operations. So in total we performed 3 operations. So our answer should be 3 because 3 is the minimum number of operations that we did. And yeah, if you see, answer is also 3. But how we can generalize and how we can find a general solution for all the test cases? So let us see now. So what we can think now? So let's say our string 1 is heap, string 2 is p. Let's say this p has some size m which is equal to 3. This heap has some size n which is equal to 4. So let us say for now. Now one thing that comes into our mind, or the intuition says that we will not alter the common elements that are present or the longest common subsequence. So we will not alter the LCS of these strings. Now why? Now if there is some common element that is present in our both the strings, so obviously there is no point in deleting these characters or adding these characters again at the same position, because that will obviously maximize our number of operations. So we will not alter the LCS. Now so what we will do, first we need to extract this LCS from our string 1. Now how will we extract this LCS from our string 1? Now our string 1 has size of 4. Our LCS has size of 2. Now in order to extract this LCS, what operations we need to perform? Obviously we will delete some characters. How many deletion we will perform? That is 4 minus 2, that is equal to 2. So we need to perform 2 deletion operation in this string heap in order to extract e and a. And obviously we will delete h and p in order to get ea. So in general we can say that in order to extract this LCS from our string 1, we will perform deletion operation, and that deletion operation will be nothing but n minus length of LCS that we have. That is for sure. Now what we will do, so let me erase this first. So now till now we have this string with us. So our string 1 is converted into this EA. Now we need to convert this into PEA. So this EA and EA are common, that we know. So we need to add some characters, then only we will be able to convert this string 1 into string 2. So how many characters do we need to add? If you observe this carefully, this EA and this EA is common, so we don't need to add these characters. So we need to add the remaining character. So how we can find the remaining character? So size is 3. So 3 minus the common element is 2, so 1. So we need to add one element in order to make this string 1 into string 2. So how we can generalize that? So we need to perform some insertion operation. That insertion operation will be nothing but m minus length of LCS, obviously. So after adding that particular character, what our string would look like? Our string would become like this, PEA. This EA was already present, we added this P, and so our string 1 now becomes equal to string 2, and that is what we need to do. And this is the number of total operations that we performed, and these will be always minimum. So how we can say how many number of operations are we actually doing in total? So in total we are doing deletion plus insertion. So in total operations we are doing are n plus m minus 2 times the length of longest common subsequence. That is what we are doing. So first of all, what we need to do? We need to find the length of longest common subsequence. We already know the length of string 1 and string 2. So we will just put these value in this equation and we'll get this answer. So this is how we will do. And for LCS, this is LCS is the prerequisite for this question. So LCS is just simple. So I can just tell you how we can perform the LCS function. So let's say we are initially at the starting position. So what we are doing, if we have some common element, let's say I am iterating here with the help of I pointer, iterating here with the help of j pointer. So if we have any common element, so str1 of I is equal to str2 of j. So obviously we find one common element, so we will add 1 to our answer and then solve recursively. We will solve this with the help of dp. So yeah, we will call this solve function, and then we'll increment both I pointer and j pointer ahead. Now if currently there are no common elements, so we'll try both the possibilities, first by incrementing I pointer only and then by incrementing j pointer only. So this is what the basic LCS looks like. I will not explain in very much detail, otherwise video will be very long. But yeah, LCS is the prerequisite and this is how LCS would work. So let us dry run on this again sample test case to see actually this equation works or not. So let us dry run now. So this is the second example test case that I have taken to dry run our algorithm. So string 1 size or string 1 length is 13 and string 2 length is 5. So first what we need to do, we need to find the length of longest common subsequence. So how we can find that? We will not apply that algorithm because that will be very long, because that works on dp. So we can just visually see for now. So LCS here will be this geeks, and this geeks is of size of length 5. So our LCS is 5. So first of all we perform deletion operation. So our deletion operation will be what? So our deletion operation will be n minus length of LCS. So our length of LCS is nothing but I have stored in variable LCS, so n minus LCS. So this n is 13 minus LCS is 5, so this will give me 8. So I need to perform 8 deletion operation. Now we need to perform insertion operation. So how many insertion operation? We have seen m minus LCS. What is the value of m? M is 5, LCS is also 5, so it is 0. So we don't want to add any character. So in total what we have seen, it is nothing but n plus m minus 2 times LCS. So either way, first you can just pick out deletion operation, then insertion operation, add both of these, or you can just directly put the value in the equation, so you will get the same answer. So let us just put the value in this equation. So n is 13, m is 5, minus 2 times LCS. 2 times LCS is what? 10. So 18 minus 10, that is equal to 8. So 8 should be our final answer. So let us see. So even if you just add these two, you will also get 8 only. So this both is same, obviously you can just see it. So 8 is our final answer. So let us see if this 8 is correct or not. So yeah, if you see the second example test case, 8 is our output. So yeah, our algorithm works completely fine. So this is how our algorithm will be working. So let us write the code now and understand in more better way. So let us see the code now. So first of all, we will declare the length of both the string str1.size int m equal to str2.size. Now first we need to calculate the length of longest common subsequence, and we will store it in our variable LCS. So we'll find it with the help of solve function. Now after getting LCS, we just need to put our value in the equation that we have seen. What was that equation? N plus m minus 2 times the LCS that we get from our function. So this is what we will get. So let us store this in some variable answer, and in the end we just need to return this answer. So the main fundamental thing in the question is to find the length of the longest common subsequence. So let us write this function to find the length of longest common subsequence. So in this, the parameters will be string 1, string 2, the pointers by which we are iterating. So initially both will be pointing to the beginning of both the strings, as well as will pass on the length of both the strings. So also let me declare the DP. So the DP size will be here. So let me see the constraints. So it is 1000. So to be on safer side, we can just write 1002. So yeah, so just we will mem set this DP. So DP comma -1 comma size of DP. So yeah, we have initialized our DP with all values as -1. Now we'll apply the DP algorithm to find the length of longest common subsequence. So we will write this solve function now. So I am taking this string name as string A comma string B, and we are iterating on string A with the help of I pointer. We are iterating on string B with the help of J pointer. Length will be n, length will be m. So yeah, so what will be the base case? If any one of the pointer reaches to the end of the any of the string, that means we can't find any common elements now. So if our I is greater than equal to n, or our j is greater than equal to m, so we need to return 0, because we'll not find any common element now. So this will be our base case. Then comes the memoization condition. So what is memoization condition? If dp of I comma j is not equal to -1, simply return that dp of I comma j. So we might have computed earlier, so we just need to return that value. We will not compute that again. Now what we have seen, we can have two scenarios. Either both elements are matching or they are not matching. So if both elements are matching, that is a of I equal to b of j. So what does that mean? That simply means that this is the common element and we need to increment the length. So we'll simply return dp of I, or let me just write in simple way, we'll simply return 1 as the length because of the common element that we are getting, plus we'll call the recursion to solve the further scenario. So a will be as it is, b will be same, and since we find the common element, we'll increment both our pointers I and j. So I plus 1 comma j plus 1 comma n comma m. Now since we are writing a dp code, so we'll just store it in our dp table. So dp of I comma j equal to 1 plus solve of this. Otherwise what can happen? our elements are not matching. So in that case, what we have seen, we'll try both the possible scenarios, first by incrementing only I pointer and then by incrementing the only j pointer, and from whichever scenario we are getting the maximum length, we will take that. So how will we write that? We will write solve function. So one will be a comma b comma, first we will only increment I pointer, j will remain same. And what can be the other possible scenario? We are only incrementing the j pointer and I will remain same. So this is the case that we are taking. So whatever we are getting among both of these, we will take maximum of these. And since we are writing the DP code, we will just store our answer in our DP table. So this is the LCS code, and this is the entire algorithm that we have seen till now, and this is how it will work. So let us see if this code get accepted or not. So yeah, our code got accepted successfully. So hope you learned from this video. Thank you.